It's like building a ship in the middle of the ocean from the keel up, from laying the keel all the way up. And of course you got to float and you got to sail, and all this has to occur while you're actually building the ship, and that's what the station is like.
If you're building the International Space Station in as unforgiving a place as Earth orbit, you do things in a certain order for good reason. Power is a top priority. You need enough to make everything work. The solar array wing on the S4 truss marks a turning point in station assembly.
We really had to build up enough of the infrastructure, both the power and cooling infrastructure, so that when we plugged the partner modules in, we would have a robust system that we wouldn't have any problems that would cause them to lose at least the minimum amount of power they needed to stay, to keep their systems warm enough that they wouldn't have any problems on orbit.
The S4 solar array wings provide that power. The next thing the station needs before new laboratories from Japan and Europe can fly is a place to put them. A second connecting node, about 5 feet longer than Unity, is coming up on mission STS-120. Node 2, named Harmony, is the first new living and working space added to the station since Pirs docked to Zvezda in the summer of 2001.
Node 2 is a very big deal, and it's a very big deal for several reasons. A, once it's connected in its ultimate home on the front end of the station, it will provide extra crew quarters for hopefully a crew of 6 sometime in the near future. And it will also provide the connecting points for the Japanese module, the GEM, Kibo, and then the Columbus module from the European Space Agency.
On the flight that delivers Harmony, astronauts use the station's Canadarm2 to move the P6 truss from atop the station out to the port end of the truss. When its solar arrays are unfolded, the station will have 3 times the power generating capacity it did during the first 6 years that expedition crews lived on board.
And we're going to get additional solar arrays that have already been used on the station and get additional solar array capacity to make sure we get additional energy supply in order to be able to get Columbus module from the European Space Agency on board.
And of course, Columbus will expand the scientific capabilities of the International Space Station, and we are all desperately waiting for the moment when Columbus will be docked to the station.
The European Laboratory Module, 22.5 feet long, more than 14.5 feet in diameter, will be delivered to the starboard side of Node 2 on shuttle mission STS-122. Columbus will house up to 10 experiment racks. Researchers on Earth and the crew on orbit will join forces on experiments in life sciences, materials sciences, fluid physics, and other disciplines.
In future, there will be more of my colleagues from the European Space Agency, from the Japanese Space Agency, and also from the Canadian Space Agency, which will be part of long-term crews. And I think all of the agencies that are involved in the ISS program are looking forward to the moment when we really can utilize the station for its originally designed purpose to act as a multifunctional research laboratory.
The ISS laboratory inventory expands again on the next shuttle flight when a pressurized logistics module for the Japan Aerospace Exploration Agency's science facility is delivered. 2 later shuttle missions deliver a 36-foot-long pressurized laboratory module and dock it to the port side of Node 2. Reposition the logistics module, install 2 robotic arms, and plug in 2 platforms for experiments that are to be continuously exposed to the low Earth orbit environment. Arriving along with that first component of the Japanese laboratory Kibo, which means hope, is the final component of the Canadian Space Agency's Mobile Servicing System. The Special Purpose Dexterous Manipulator, known as Dexter, is a 2-armed robot that can be attached to the station's Canadarm2 or to the mobile base system. Flown by crew members from inside Destiny, Dexter will perform intricate maintenance and servicing tasks that otherwise require an astronaut to make a spacewalk. In the following years, the station's science capacity will expand again when 2 new Russian laboratories are installed. When it has more labs, the station will need more supplies. The European Space Agency reinforces the supply line with its automated transfer vehicle, a series of uncrewed supply ships with 3 times the cargo capacity of a Russian Progress vehicle. Deliveries to ISS via Progress and Soyuz, ATV and Space Shuttle will be augmented later in the decade by JAXA's H-2 transfer vehicles, which will have capacities slightly smaller than the ATVs. A shuttle flight in 2009 finishes outfitting the station to accommodate 6 crew members full-time. And a year after that,
the last thing that we're going to put, like the cherry on top, we're going to put the Node 3 on there, which will largely be much of the regenerative eclipse capability will live in there, as well as crew habitation capability will be distributed between Node 3 and Node 2. So that's a pretty important module for us as well.
By that time, all of the partner agencies will have their own control centers monitoring station operations. NASA's Flight Control Room at the Johnson Space Center in Houston, and Payload Control Center at the Marshall Space Flight Center in Huntsville, Alabama. The Russian Mission Control Center in the Moscow suburb of Koryolov. CSA's Mobile Servicing System Operations Complex in Saint-Hubert near Montreal. ESA's Columbus Control Center outside Munich to monitor science operations in Columbus. And a second control center in Toulouse, France to control the flights of the automated transfer vehicles. And JAXA control teams at the Tsukuba Space Center north of Tokyo, overseeing science operations in Kibo and the flights of the H-2 transfer ships. Although the space shuttles will be retired by 2010, the International Space Station will be the destination for the first flights of the next generation American spaceship, Orion. The vehicle that will take us back to the moon and then to Mars will be part of the international effort to use ISS to learn how to achieve our vision of space exploration.
The contribution of ISS is an important one because, really from a long duration standpoint, we need to understand again what the human physiology reaction to those kinds of things is and what kind of countermeasures we can invoke in order to mitigate the deleterious effects of those long duration stays in orbit.
And it's very important that not just the partners in terms of our agencies to be excited about this. We need the world to wrap their arms around the International Space Station, realize it's there, realize what it can do, and energize us all to make this next step into exploration.
Eight, 7, 6, go for main engine start. 4, 3, 2, 1, 0, and liftoff of Space Shuttle Endeavour, expanding the International Space Station while creating a classroom in space.
After a spectacular liftoff from Kennedy Space Center in August of 2006,